All right, hello everybody. This is Jorge Fernandez here with KETIV Technologies, and I'd like to welcome you today to KETIV AVA, Autodesk Virtual Academy. And today with us we also have Dave Graves from Autodesk, one of our simulation specialists that we have that we work closely with for a lot of our simulation opportunities and with our customers to make sure everyone's headed in the right direction when it comes to simulation. So for those of you who haven't joined us before, what KETIV AVA is a live year-round web-based learning. It's every Thursday at 10 a.m. And we'll continue doing these, as we said, year-long, not just this year, of course, but next year and the ones after. And topics are constantly being brought up. Some of them are by people that are making suggestions, of course, and also we'll kind of bring in some stuff that we think is relevant, of course, as well to people using Product Design Suite. We do have some upcoming sessions. Next week is going to be Shape Generator, and then there'll be some AutoCAD Electrical as well. So if some of you have, other colleagues that use AutoCAD Electrical might want to attend that. It'd be great to get that going to them. And there is actually an R3 update to Inventor that just came out as well, and we'll have more information for you on that, of course. Just a couple house cleaning things really quick. Don't forget there is a little chat window that you get with GoToMeeting. So you should see that on the right-hand side, typically in your control panel. So if you have any questions at all that you want to give us during this session, by all means, please go ahead and type them in as well. We will have a Q&A session at the end. Don't forget, we do have a bonus session today also. So after we're done with the main topic today at 10:30, we're going to have an Advanced FEA session as well. So please stick around for that also. So the goal for today is, for this first session, I should say, is we're going to go over Inventor Static Stress Analysis right inside of Inventor Professional. And we're also going to take a look at a parametric design study, which means that we're going to be able to manipulate a parameter inside of Inventor so that we can get an idea of what it would look like in these two different scenarios without having to start a brand new simulation. And since we only have 30 minutes, that's going to be the focus of today, but I do also want to go over some other capabilities you have inside of Inventor Professional, which is Modal Analysis, Frame Analysis, and Dynamic Simulation. So we'll bring up a few quick examples and show you what you can do inside of there as well. So let's go ahead and kick it right off over into the live demonstration where we'll take a look at all of this. All right. So what we're going to be looking at today is we have a fork here, a suspension fork for a bicycle. So this is the assembly we'll be working with mostly today. And we want to analyze this part inside of here. So this is inside of Inventor. It's not an add-on or anything like that. It's inside of Inventor Professional. And we're able to do this type of thing by, just going over here, our level of detail, we can simplify this. Don't forget, you can do this with both assemblies and parts. It's not just one or the other. But for the case here that I'm going to do with the parametric design study, I am going to go to the part itself. So let me go ahead and open that over here. So here's the part. We're going to go ahead and simulate it inside of here. And how we get this started is by going over to our environments. Before I do that, though, and go to stress analysis, the first thing I want to do is I want to identify which parameter is it exactly that I want to be able to manipulate. Which one is the one that I want to go inside of stress analysis and say, well, what's going to happen if I change the height of this or the thickness of this part, for example? So let me go ahead and identify that right inside of here by going into one of my sketches. And we'll just change this height. And actually, we're not going to change the dimension just yet. What I'm going to do is I'm just going to go ahead and give it a name. A little shortcut for you guys in case you didn't know. You can actually rename parameters right inside of here. I'm going to do HT equals, for example. And that actually creates the equation for us. And we're going to verify that by going to our parameters up at the top of the toolbars here in our quick access toolbar. And sure enough, we'll notice that HT, I went a little too fast there, sorry about that. There it is. HT is right in here. I'm going to go ahead and select this to be an exported parameter as well, by the way, in my parameters list by selecting this right here. Alright, with that done, I'm going to go ahead and finish this sketch. I didn't change the actual dimension right now. All I did was just simply add that equation for it. Now that we've done that, I'm going to go to my Environments tab and go to Stress Analysis over here. Notice since I'm inside of a part, I'm not seeing other options like dynamic simulation for those of you that are going to see that, or we're going to see that in a little bit, but since this is just a part, we only have stress analysis as far as FEA goes. So again, this is meant to be mostly introductory at the beginning, at least first here, where the first thing you're going to do is you're going to create a study, and you go up to the top left-hand corner. You're going to work yourself to the right. Now, what people before who have used already FEA have done previously is they'll come in here, they'll select the options they want and move forward. But what a lot of people don't realize, and even I forget sometimes, is that under the drop down here, you have this Parametric Dimension option. That's actually what's going to begin the process for you to be able to select that parameter and make it something that you can actually use inside of here. So we're going to go ahead and choose that. Notice we do have Modal Analysis inside of here as well. What Modal Analysis does is allows you, it'll create the frequency range for you, or you can type it in as well to see what type of, at what point you might expect some failure depending on the type of vibration you have in here. So there's a nice little set of tools here to be able to do it right inside of Inventor as well. Next week, you'll actually look at Shape Generator, which is something new that came with R2. Just a little preview for you. That's where this comes from, so you might have not seen that before. It wasn't there before until you install R2 of Inventor 2016. Down at the bottom here, you'll notice there's this Contacts section. And what this is if this was an assembly, in here you can set a tolerance for the space between parts and for it to automatically pick up if it's going to be bonded, is it going to be separation, sliding, no separation, and so forth. So this will be the default that will be given for you if there's if it meets this criteria, if it meets its tolerance between parts that might be hitting each other. Of course, we're doing just one part here, so we'll do that. One other thing, though, is the model state. We'll come back to this again later when we go to a dynamic simulation analysis. But what this will allow you to do is say, well, I want to see specific parts in here, visibility states, or maybe in a certain position, or with certain parts suppressed, because you don't necessarily want all the parts in there. So this allows you to go ahead and select which configuration you need to begin this analysis. Alright, we'll select OK. The first thing I'm going to do now is I'm going to tell it exactly which parameter I want to bring over. So if I go to the fork crown right here in the browser, you would right-click the extrusion it's a part of and click Show Parameters. This is a really crucial step. If you forget this part, it's easy to go back to, of course, but you do need to do this in order to have the parameter come forward. So I'll simply select that parameter, HT, for height. And now that I've brought that parameter over, I'm going to click on this button right here, Parametric Table, which is actually going to bring up that parameter that I selected. Notice it shows the value for it right here. And then what I can do is I can say, well, I'm going to add a value to this by just simply clicking in here. So if I wanted a height also of 0.6, and by the way, it does have to be in order here, so if the number's smaller, it has to go in front. If it's bigger, it has to go after it. And then I separate both of them with just a comma. And then I have a little slider bar right here. I could do multiple values, not just one. I can even right-click this as well. I can remove this parameter if I needed to at this point. I can generate a range of configurations, so I can say it can be any value between these two. For this configuration. But if I just simply click on the left-hand side here, it shows me that it's not available for this value, the 0.6, which is the current value here. So what I can do is right-click and generate current configuration, and it's computing that geometry, and now it shows me both options there. So I want to pause there for just a moment and just make sure we understand what's going on here. instead of having to set up two different simulations with two different heights here, I can just manipulate the parameter through the parametric table down here. So there's a lot of time savings there. You're able to quickly, do some validation and not have to go back and forth all the time necessarily. So nice little feature to have there. The other part is I want it to report back to me what are some of the different, values that are happening with these two different configurations. So I'll right-click on the top portion here and say Add Design Constraint. Here I can say, well, I want to be able to see what the mass is for both configurations. Click OK. I'll add another design constraint for the von Mises. And let's also add displacement and safety factor. By the way, something I glanced over here is notice on the right-hand side, it gives you the opportunity to select which geometry. So if you were looking at an assembly, you could say only select the geometry is what you want to see these values for. All right, let's expand this down just a tad. Just to the right of those constraint names, we have constraint types. And this allows me to say, do I want to see the upper limit? Do I want to try and keep this to a minimum? Do I want to fit it within a certain range or avoid a range? And then what it'll do is it'll actually report out to me what those were over here, if I was on that limit or not, with a simple red, yellow, green coloring to let me know if I actually met that criteria or not. I can also just say view the value, so I can see what the different values are for those two different configurations. All right, so now that we've set up the configuration, let's take a look at setting up the rest of this. So the first thing is we want to assign material if it isn't already assigned. I noticed right here that sure enough it is assigned. This is just simply by using the material library that comes with Inventor. I can also override it at this point. Maybe that was selected at first, but I want to explore another option. So you can do that right inside of here. So we'll leave aluminum 6061 for now. Now we'll apply constraints. You notice there's three different types. So it could be frictionless, for example, where maybe we constrain the bottom of it so that we make sure it doesn't move up and down, and instead it can just move on the XY plane, for example. For now, what we know we want to do is we're going to fix the side holes here. So by simply selecting the two holes, we'll be able to do those two. And now we're going to add a force right in the middle. So what I'll do here is instead of selecting geometry in here, I'll tell it exactly which direction I want it to go in by using the vectors here and saying that in the Z I want to go negative, in other words down, 5,000 pounds. And there we have it. Notice you do have other options, of course. So you do have pressure, you can add moments, bearing loads. You can even add gravity into this, or remote force as well. So you have a few options in here right inside of Inventor. You also have the section for contacts. So again, if we did have an assembly, it can automatically add contacts to it if I didn't at the beginning, or I can always add my own manual contacts as well. One example I've seen before is, let's say there was a part underneath here and they were screwed together. You typically don't want to do an FEA with the bolt in here unless you had a specific, analysis of the bolted connection. So you could just say that you want to put a manual contact between this surface and the one below it, and that would actually add that type of contact inside of there instead of having to model a bolt and put it in here. Now, just to the right of that, you'll notice this fine thin bodies. So one of the things that this is one of the things that was added to Inventor. I want to say maybe 2 or 3 releases back. That when you want to do like sheet metal or something like that, it really wouldn't deal with it that well. And what it is the thickness of the material compared to the overall surface area of it. It did not like, and then you want to make sure you have a certain amount of elements in between. So that's why there's this fine thin bodies option to be able to use a plane or a surface instead. And then finally we have the meshing. So in here we can turn on the mesh view, and then there's mesh settings as well. So what this allows us to do is control how big is it going to, to what size is it going to break the entire part down into different sections or elements that you can do inside of here. So I can change this value, for example, and control it just a little bit more. what the element size is, if I want to specify the turning angle, the maximum turn angle for these, or even if I want to create mesh on a curved surface as well. So once I've decided what I want for that, we can go ahead and click Mesh View, and it'll create the mesh for us on this part. There are some other options here as well. For example, the local mesh control. If I just hover over that, you'll notice it'll allow you to select on a specific surface and control that surface a little bit more. And refine it and make sure you're able to break it down a little bit better and have a more accurate answer on that. The last button here is Convergent Settings. What this does, it allows you to see, to refine the results and go through different stages where it looks at it over and over again and make sure that it actually converges. If you notice that little graph we see there, it kind of it does a quick slope up, and then it starts to kind of level out. So what you're looking for is for it to actually level out. So, just a few tips for you when you're working with this. Of course, these are things that we usually go over in training, and there's also stuff in the help documentation that tells you a little more information about it as well. All right, now that we have the material, we have a constraint, we have a load. Since this is just one single part, we didn't have to do contacts. We'll go ahead and do a simulate now and run it. So here's our results. What we're seeing here is the max. This does not include, what the maximum yield is for this part. So this is just showing me the max that it's showing. So if I actually wanted to type in the true yield of it, or if I knew what value I was trying to stay under, then I could go back to the color bar here, and instead of it being showing me the maximum here and minimum, I could set these up myself. So I can come over here and say, well, I don't want it to go past, let's just say 20, for example, for purposes of showing you the color bar changes here. And now we see a little bit more red there, of course, because the max we want is 20. We can always also find what the max is by selecting these options here, like the maximum value, to see where that's at. We could turn those off and on. And we also have a probe option, which allows us to select a location, puts a probe, and lets us know what the value is at that point. Right now what we're seeing is an exaggerated look of this. I can always go to my actual, take a look at a side view and see what's actually going on. Maybe I want to look at displacement instead. So over on the left-hand side, I can take a look at that. And there it is. Now down at the bottom, if you remember, we have these configurations. So what I can do is I can toggle back and forth between the 0.6 and the 1.2, and you notice the graphic updates, the bottom values update, and the results update too. So I have this quick information without having to note it down anywhere necessarily. So that's always a nice little feature. Now we're starting to see, why we want to use some of this parametric table information, for example, right? We can also animate these. So if we just hit the animate button, we can hit play, and we can see this animation. And you know what? I'm going to stop it here. I'm going to bring up the scale just a little bit so it's a little easier to see. We'll hit animate and play it here. Now we can see the animation of this displacement, which is pretty minimal from what we see here. This can be recorded out, by the way. Keep in mind that's not a rendering per se. It's just a quick video to be able to show it to other people or to keep for my own records for this simulation. And speaking of records for the simulation, you do have a report that you can generate from this. It's an HTML, and what this will do is it'll record the information of who created this. You can have your own company logo if you want, any summary you'd like to type up for this, what the image sizes are you want to use for it, as well as what property information you would like to have, or maybe just properties that actually have values in them. Notice you can have multiple studies. Something I haven't done just yet is I can copy the simulation study and do multiple ones and include it all in one report. And then finally, which format I want it in. So HTML works out just fine. And what it does, it takes screen captures of everything and actually records the input you had for this simulation, all the results. They all come up within this one report, and you see it right now as it's moving forward. It's actually recording all those results. We'll let that finish off here. All right, and here's our report. As I mentioned earlier, it's a quick report just putting down some of the information that I input into this, material information as well, mesh settings, material settings, and screen captures of the faces that were selected for this. All right, we'll go ahead and exit that. And then, as I mentioned earlier, I can take the simulation and I can actually copy this study. I can create another one based off of these things, so I don't have to start all over again necessarily. One other quick thing also, since I'm looking at the browser here, if you did want to apply a local mesh control, this is where you would do that too. You would right-click, hit local mesh control, and we can do that to specific faces on here. So just a little useful information. Hopefully this gave you a little introduction to static stress analysis. I'm going to exit this part here. And before our half hour is over here, I want to just show you a couple other quick examples. So I mentioned we can also do frame analysis on this. So if any of you are on this session and you do any type of framework, structural steel shapes and stuff like that, we can actually do a frame analysis on those. And where you'll find that is if you have Inventor Professional, you'll see that in the frame generator section, for those of you that have used that or are looking to use something like that, this will automatically allow you to bring in structural frame members based on 2D sketches, 3D sketches, or edges of an actual 3D model, and then do an actual frame analysis on this. So what the frame analysis will do here, and I just set one up here that I already had a finished example, is again we can look at displacement. It's a nice way to be able to do this so that you don't have to do it through the FEA static stress analysis. We can get beam details of this. So let's say I want to get more detail on this specific beam right here. There's a beam detail button that allows me to see where the forces are, where the moments are for these, and what direction, and see what those values are, all within this nice little dialog box as soon as I select a beam. So a nice way to be able to get all this information on a beam analysis without having to use the FEA standard static stress analysis inside of FEA. Again, you get tools like being able to animate. Through here, you'll see there's a few different things to do now. For example, putting in a fixed support down at the bottom. That's where it's being held from, of course. The types of loads here. So you have a continuous load, for example. There's axial moments that we can supply on here, or even have a continuous load with different loads on the different ends of it as well. So again, I just want to show you an example of something else you can do right inside of Inventor using the tools you might already have. One other quick example I wanted to show you was dynamic simulation. So for those of you that don't know, there is a Kinematics that's built inside of here as well. Let me just open that up really quick. In this example I'm showing you for here is a yogurt cup filler actually, and what this allows you to do, let me go to my environments, and now we'll see there's dynamic simulation. We can actually simulate the motion of this and see what some of the forces are on here. In this case here we have this pin that's on the right hand side that we want to simulate and see what happens when it actually hits down here. What type of forces are we getting out of it? That's maybe on this connector right here. So in this example, there's different joints that are going on in here, allowing me to do this, basically like constraints that are coupled together to make these joints. And I can run this here, and it's hopefully there's not too much lag over the internet, and you're seeing that the entire filler station comes down, and then there's going to be forces that are applied on this as well. So while that's happening, we can have what we call an output grapher, which shows us what those values are as it's moving, and we can then find what the maximum values are also and export those out to FEA. You'll notice there's an export option in here, and actually get those results and do a stress analysis on the part or again on an assembly without us having to insert the moments, the forces, and so forth. Another great tool, I know I'm just touching the surface on this, but of course we will have more sessions on AVA on these types of topics, so stay with us, stay on our list, of course, and we'll be sure to have a session dedicated to these topics that we're touching on right now. Okay. So, in summary for this first session, again, don't forget we have a bonus session for those of you that just might have joined a little later than others. We have a bonus session coming up here at the top of the half hour here. And to summarize this one, we looked at doing static stress analysis inside of Inventor, where we did a parametric design without having to go back and forth and change parameters. That's one nice way to kind of look at different configurations, if you will. There is modal analysis that's available inside of there, where I showed you really quickly the interface where you can do that. And then there's dynamic simulation and frame analysis as well. So again, we'll have topics on that coming soon, I'm sure. We want to make sure we have a well-rounded AVA sessions coming up, but those are things that you can do inside of Inventor. So before we go into the next bonus session, I'd like to go ahead and have a Q&A and see if I can get any questions answered for you. So the question here I'm seeing, does the contact section under study type apply to all types of analysis, static, modal, shape generator? So the contact section is for, yes, static and modal analysis. I'm not sure about shape generator. I want to say shape generator is just for single part mode, actually, but we'll confirm that by next week for sure. But yes, as long as it is an assembly, you will have the option for the contacts. Let me read another one here. Can you do an assembly FEA analysis where a part displaces/deflects to the point where it comes into contact with another part? Will it transfer the stress to the second part? The answer is yes, with dynamic simulation. You can set that up. Of course, it is all part of the setup and making sure you set up the contacts correctly as well as all the joints to be able to move or enforce motion for all the parts. So the answer to that one is yes. Oh, this is an interesting one. What is the recommended RAM requirement to run the simulation effectively? So, I don't think there's a... I haven't come across where people are saying it's not running because of my RAM, but I would have to say I would at least try and go with 16 gigs of RAM. I would say that's what I'm running right here, and it's running pretty smoothly. I'm not sure if you got too much lag over the internet, but I always recommend 16 when possible, or higher, of course. And then we have a question here, how well does Inventor handle pressure vessels stress analysis? That one I might have to get a little more information on, actually. Yeah, go ahead.
Hey, Jorge, can I hop in? It's Dave Graves here from Autodesk. So pressure vessels are a little bit challenging in it can handle somewhat of a pressure vessel, but it's going to assume a constant pressure unless you split surfaces. And I know lots of times in pressure vessel design, it requires we call stress linearization to kind of check against code. So Inventor FEA does not do that. So it can help give you some insight, but there's some other tools that can take it a little step further.
Oh, great, thanks. We have another question here on weldments. It says, do weld connections have to be established beforehand in the model, or is it established during the connections phase in the FEA? I believe from my experience it's been better to put it into the model. In other words, actually bring those parts together, if you will, and simplify it that way instead of having an actual weld bead on there. I believe that gives you more accurate answers. And I don't know, Dave, if you can expand on that a little bit.
Yeah, it really depends what you're trying to accomplish with the weld. If you want to actually study a single weld itself and look at how it performs, you could bring in the welded contacts what Jorge is talking about is most people just leverage the bonded contact in Inventor, and the two parts are bonded versus welded. So it just depends what you want to study and what you want to understand a little better. If you really want to investigate the welds, then bringing the welds in and having some contact between the welds and the part might be a little more accurate, but there are some challenges with welding. But again, we can talk more about that at another time.
Right. Another question is, what level of Inventor is this included in? I assume you mean all the different analysis. And what that is, so this is Inventor Professional, which comes with Product Design Suite Ultimate that you saw. Everything you saw right now is all inside of there. So it's all included with Inventor Professional or Product Design Suite Ultimate. One last thing I forgot to mention earlier also was when we did the frame analysis, some people might wonder, well, why would I do that instead of the FEA, the standard static stress analysis inside of Inventor? Well, the thing is, when you use frame analysis, it actually breaks it down into the different beams. And so what you're seeing there is it's the actual line without trying to figure out how you're going to work with the thin bodies and surfaces and midplanes and so forth. Instead, it breaks it down into those different beams. All right, so, oh, we have one last question here that came in. Will the frame analysis also incorporate other custom parts? You know what? I'll have to take that question offline here. I was looking into that right before this, actually. It looked like it might, but I'm not exactly 100% certain. So I'll take that note there as an action item, and I'll get back to you.
Yeah, Jorge, let me add a little to that while you're there. It's just that the frame generator, the frame analysis really just is meant for kind of beams that have uniform, different, or not uniform, but constant cross sections. So you can put maybe your own custom cross section into there. But if you wanted to do a bracket and kind of do a mixed modeling where it's beams and a solid element, that's not going to work in frame generator. But I think what you're going to, if you stay on a little bit, we start talking about our In-CAD product. That's where you can do things like that.
Awesome. Yeah. All right, so let's wrap this one up here so we can get into the bonus session. So some recommended next steps. There are tutorials inside of Inventor for what you saw today that give you just a quick overview of it, how the tool works and so forth. Of course, there's always training available for this as well. We can always talk about how we can kind of get you going there and what you might need to do. And don't forget, KETIV can always help. So, by the way, Dave Graves will be in our Southern California office. If some of you are there local to the Southern California office, we could definitely maybe schedule something next week, Tuesday or Wednesday. So keep that in mind if you want to talk a little further about trying to leverage these tools as well. So let's move into the bonus session here, which we're calling Advanced FEA. And we're going to stick, for the first part of this, we'll stick to the same assembly we were looking at earlier. And what we're going to do, the goal of this is to now look at nonlinear analysis. So inside of Inventor Professional, you actually can only do linear materials, meaning metal materials, for example. So plastics and rubber, for example, are nonlinear, and that we would cover inside of here. We're also going to take a look at, well, this is a great first step, but how long is this part actually going to last? Let's look at a fatigue analysis and see at what point can we expect this to break? Is it going to last the amount of cycles that we actually want it to? And then there's also thermal capabilities or heat transfer that we'll take a look at. And how we're doing all this is through Nastran In-CAD. So this, I want to make clear, is a separate add-on to Inventor. It works inside of Inventor. It actually even works inside of SolidWorks in case you have other colleagues that want to use it too. But this is a separate add-on called Nastran In-CAD. And so what Nastran In-CAD is an embedded tool inside of Inventor. It also has flexible licensing, so it has a network license to it. It has more capabilities that adds to what Inventor already has. It also has some that Inventor already has as well. And it is powered by Nastran, which is a very well-known solver out there as well. So we'll go ahead and go into the live demonstration here, and we'll see how we can get a little more advanced, if you will, with this. So back to this assembly here. What we're going to do now is we're going to use this level of detail in here to bring it down a little bit. So by you going to the simulation level of detail, I'm going to basically suppress some of these other parts here to get to just this one part and apply the information we want to it as well. Excuse me. Okay. So in order to go into Nastran In-CAD, we'll see that in our Environments tab now, we have Autodesk Nastran In-CAD button in here that we can pick. It's very similar to the one in Inventor. That's one of the things I really liked about this tool personally, is that if you've used the Inventor FEA Professional stuff, it's very similar to it, where you still set up your material, your constraints and loads, and it's all inside the ribbon here in the same order even. So inside of here, we can choose what type of analysis this is. So I can edit this, and we'll see the different types right inside of here. So there's linear, static, there's nonlinear. So let's say we wanted to make this, for example, a plastic part. We can do that right inside of here by saying that this is a nonlinear static analysis, for example. So we can do that. We can move forward and start to change the properties of this by saying what type of materials we want to apply to this part. So if I go to my materials here, I can choose a material by going to the actual material library. And let's see, we'll go with where's my regular plastic here? We'll go with polypropylene. So from here we can, you'll notice it'll fill out the information for that actual, for the material that we have in here. Notice that down here also we have different things that we can add. So if there's nonlinear material in here, we can choose the type of material it is, and we can adjust the stress-strain curve inside of here as well as needed, if needed, but it will fill in the information according to the material that you've chosen as well. You'll notice in here is also fatigue information. So we can come in here and type in what these different things are. So for example here, what the slope is of the fatigue for this material. Maybe we want to put in the ultimate stress for it as well. The number of cycles that we want it to run. Account for surface finish, we can do that inside of here as well. The endurance limit. And finally the slope for this as well. So we can insert this information right off the bat here so that we can get a fatigue analysis going of this. Oh, I forgot to actually assign it to the part, I think, here. 1 second. All right, there we go. So now we'll set this up similarly to the way we did before, actually. We can come over here and start putting constraints on it, for example. So I'll come over here, pick the surfaces. Very similar to what, like I said before, but we have a few more options here to do the types of constraints. Instead of 3 different buttons, now we can come in here and set this up according to this one dialog box instead. The load, same way. I can come in here and tell it what type of load. Notice there's forces, there's moments, gravity, remote forces. All of that is all inside of this dialog box instead now. And then I can go ahead and give it the the force I want. So we'll do negative 5,000 for this as well. Again, we have contacts. You notice it actually looks very similar to the one we saw before, where you have automatic and manual in here as well. The mesh settings we have also that we can control inside of here. Again, we can change this element size through here, type in exactly what it is we want to do, and give us a mesh for it as well. So with our material selected, the constraint set up, as well as the loads, we can go ahead and now run this. So, think of this as another way of, when you're doing your actual stress analysis. It works great, you know, to be able to do it inside of Inventor FEA and do a linear material. But now you want to take a look at nonlinear, look at plastic, look at, you know, look at different options. Maybe you want to try and save some money, or maybe, you know, you just want to look at what the different options, or even the customer might have selected something else they want to do differently now. So in a matter of a few minutes here, or a few seconds, before a minute I should say, we're able to get these results and be able to actually bring them into here. So we can go to our options here and look at the different types of stresses, displacement, and so forth. So if we want to look at the von Mises, for example, we can go ahead and display that on here. Again, we still get a color bar that we can look at and see these values inside of here. We're able to easily probe inside of here as well and be able to see what these values are. You notice a little box pops up letting me know that this is the actual value we're getting out of this. I can easily come over here and say, you know, maybe I want to look at displacement instead. So I turn on my displacement, and so load those results now instead. And again, I can see where the max is, and I can have my probe on to see what those different values are. Now that we did that, though, let's you know, what's really nice about this is you're still inside of Inventor. So if you need to, you can still come over here, go back to the part, and make changes to this. So I can open this up and say, well, let's see what happens if now I change some of these values. So if I edit the sketch and say, well, let's change this radius, for example, now to 0.7. Let's change this radius as well now to 1.75. We'll finish that. We've changed it up a little bit. We had we had talked about that height earlier. Let's go ahead and change that too again. So we'll change this to 0.6. So quickly, I make changes. I go ahead and go back over to my Nastran In-CAD environment. And what's great is all those things still stay there, the forces, the constraints. All I have to do is just update the mesh now. So I hit the simple Update All button, and very quickly I'm able to get back to this. Now let's change this up a little bit. Let's not just look at nonlinear static analysis. Let's actually take a look at the fatigue analysis. So down here we'll see that there's a multi-axial fatigue analysis. There's also vibration, you'll notice. Set that up. We had already inserted the information for the material, for the stress strain curve, and let's go ahead and just run this now. Oh. Let's just make sure the property is right here. Oh, I see. Okay, let's enter the fatigue information here, which was 0.25 for the slope, 200 for 1,000 cycles, and 75. Yep, there's my XY plot. All right, let's run this again. Awesome. All right, so we can take a look at our options here. We have some more information we can look at now. I forgot to mention, by the way, we do have safety factor, of course, in here as well. We can take a look at the von Mises. We can let's cancel out of here, and let's look at the fatigue results. So if we go to the fatigue results, we can look at the life of this and see how long it's actually going to last. So we'll open those results up. So we have what we call solid life and solid damage. So the solid life, for example, is going to give us at what point is this going to break, and what this is telling us right here that it's infinity. So it's letting us know this is going to last the entire life of the 1,000 cycles. And then the solid damage here also tells you what's the damage at the point of breaking, right? So luckily in this case, we're good for those 1,000 cycles. We can always go back and try more cycles, right? Maybe it needs to be 10,000 or something like that. Or maybe we want to try, well, if this ran so great, maybe I can optimize this just a little bit more. Hey, maybe this goes into the session we talked about for next week about using Shape Generator, which gives you information about how you can cut some material out of this, for example. So this is just one example of taking this further, taking this advanced. This could also be a very large displacement. Maybe the value of 5,000 pounds is much greater, and instead of Inventor FEA, it's just too much for it to handle. That's another reason why you might want to come in here. But what I also want to do now is I want to kick this over to Dave Graves, which is going to show us a heat transfer example, actually, of using in-CAD inside of Inventor as well.
Thanks, Jorge. I would say need to let my kids do a million cycles on that thing. I'm sure they'll find a way to break it. But that's the beauty of it. If you think about what Jorge did, if you're going to try to test that, who knows how long it would take you to test that? And a couple things with nonlinear, as Jorge mentioned, you could try some different parts. But another thing about nonlinear is, you could actually figure out when that thing's going to permanently bend or do some permanent deformation. So there's a lot of other nonlinear factors into a lot of things. So what else I want to talk about today is the ability to do thermal analysis. That's a question I've heard from a lot of customers that have Inventor. They say, oh, we can do stress, but can we do anything thermal? And, the answer has been no until we have Nastran In-CAD. So what I want to do is take a look at this brake assembly. So, as this is spinning around, as your brake coach, you can see my hands when I do this, as your brake pads come together, it creates some big friction and they heat up. So we want to understand how much they're going to heat up, what the temperature is going to be, maybe what the deformation is going to be. And that's really a pretty easy analysis to do inside of In-CAD. And what I want to do is much like Jorge did, is I'm going to initially just start on just the piece here. One of the other nice things is we could do things like bolted connections inside of In-CAD and a lot of other, advanced capabilities. But what I'm going to do is start here, and this is one thing that just came out in a new release of In-CAD is I'm actually going to start this out in Inventor. So in the case what Jorge did, you could do the initial linear static inside of Inventor to get some initial results, and then you could bring the results right in In-CAD and do some more advanced simulations. So in this case, what I did to run this is went through and I kind of if I go to my fixed constraint here, you'll see I went ahead and I fixed all my points to simulate the bolts holding it, and then I kind of simulated this big moment as you really try to stop it. So I put a huge torque on it just to see what the bolts would look like. And if I run this, you can kind of start seeing the stresses right inside of the bolt. So I'll give this just a second. And of course, everything takes longer when you're showing it on the web, so please bear with me here. Let's see. Come on, Inventor. Sorry about this, everyone. Come on. Let's see what we can do here. Give me just a second. Rather than you guys wait, I'm just going to open this, start this again, show you the process. I apologize. This is how you know it's live, right, when things like this happen. So give me just a second. But the idea being is you can take your static stress simulations directly from your Inventor FEA into the Nastran In-CAD product. So when this opens, we'll show you that process real quick. All right. Come on, Inventor. There it goes. All right. Here's my assembly coming up. And I'm just going to jump into the in-CAD portion of it. As Jorge said, it's just a ribbon, but I'll show you the nice thing is that we have a button here. So if you did it inside of Inventor Simulation, we'll go into my in-CAD. You'll see there's a button here that says import your Inventor FEA simulation. So let this load up. Here we go. Jorge, are you seeing that? Is everything caught up now?
Yeah, I see the
All right. So there's actually a button right here where I can say, you know what? I want to import my analysis directly from the Inventor model, and you'll see it's going to add another simulation here. So it put a model right here. It had my loads in it, my fixed constraint in it, and I could just run this if I wanted to. But in this case, I want to do some thermal. I want to see the heat effect. So I'm going to actually change my analysis type. And we're just going to change it to a, if you look here, all the types of simulations you can do now, it's much more advanced than Inventor FEAs. We have buckling, linear buckling, so we could push down on something, see what it's going to break. We can do nonlinear analysis, static. We can do transient response. We can do advanced vibration, so you can help understand, you know, maybe an off-center motor or something like that. Same thing, Jorge showed you some of the fatigue. And what I'm going to do really quickly is just a linear state heat transfer. So I'm going to break it down into something simple. Now it's going to tell me if I just want to do heat loads, I don't need all my other constraints, so that's fine. And what I'm going to do is I'm going to add some thermal loads. So if you look, oops, sorry, my window's over here. I have something called a convection coefficient. So if I don't put anything on the model, it's going to assume it's fully insulated, and basically it's going to heat up to infinity because the heat has nowhere to go. So what this convection coefficient does is let heat go in and out of the model. And we can also do radiation, right? So I'm going to do convection, and then I'm going to select the faces. I'm going to show you a little trick. I want to select all the faces except for the ones that I'm going to generate heat on. So what I'm going to do is select those two first. All right, it'll make sense in a second. So these two are ones where I'm actually going to put heat. But now if I go ahead and draw a box around the whole model, it actually unselects those and selects everything else. So just a really quick trick if I want to do something like that. And I'm going to give it an ambient temperature, you know, maybe it's, you know, 295 Kelvin or 273 Kelvin, it's room temperature. And I'm going to put up my film coefficient. I'll put a half a milliwatt per millimeter squared, all right, per Kelvin. And again, you know, as Jorge mentioned, I'm actually going to be out in the area next week. If any of you guys want to learn more, you want me to stop by. In addition to our FEA products, I'm also pretty versed in our CFE products. I'd love to hear some of the challenges you guys have with, you know, overall product development. So this is going to take a few minutes to load because it's got to go through all of these surfaces. And then what I'll do after that is I'll just pick these two surfaces out here and I'll put my kind of a heat distribution on it. Right, let me do that. The nice thing about in-CAD, as you're doing it, is giving you some visual feedback. So all these little green dots are where that convection coefficient is applied, and you can scale that and make it really prominent or not make it prominent. And then once we do that, we'll jump over into my other loads here. We'll put a heat load on here. It looks like it actually didn't take my other heat load, but I would put a heat load on here. So I would say we have a heat flux. You know, it's 150 milliwatts per millimeter squared. And these are things you could play around with, try different quantities real quick and see what happens. And rather than actually wait for to run this, let me just show you one that I've already run. So I'm going to make this active. But that's the initial setup we can do. We'll do all the conduction paths. It looks really interesting when we show this. So what I'm going to do is make this one active and load the results. Give me just a second. I swear, Jorge, GoToMeeting loves to slow down the graphics of my computer. So we'll give it just a second and want to be cognizant of your time. So what I suggest, while I show you this real quick, if you have any questions about anything we've shown, feel free to throw them in the chat window, and as we're waiting for this to come up, we can definitely try to answer them. All right, we'll bring our thermal. And real quick, we should see a temperature on here in a minute. So there's my temperature gradient, right? You can see this is probably in Kelvin. But much like Inventor, I can go through and I can start probing this so you can see what my temperature is as I move this all around. Kind of makes sense, not as much as being conducted to where the bolts are. But you can kind of see the veins in here. There is some thermal, oops, where did it go? There is some thermal properties being kind of alluded into the veins here. You can see the conduction path in there. So it does a lot of things. And then if I wanted to, we can look at, an analysis that where you take the heat transfer and you take the actual torque loading, you put it all together, and you can see the effects, the thermal expansion, as well as the results from the actual force. So we'll load that real quick. And it's always creates these wonderful images because they get scaled. The deflection gets scaled. So let me show you that real quick. There we go. We'll do. Here we go. So usually whenever you do FEA, just as Jorge kind of mentioned this, everything gets scaled excessively so you can see it. So it's not as bad as this, but it is kind of interesting. You can see, due to all the stresses, maybe you do get some rippling effect. So maybe, well, we'll change this a little bit here. We'll make the scale a little bit smaller. Maybe you want to put more veins in there to capture that more effectively, but it is kind of interesting looking at all the stresses in the model, looking at the stresses on the bolts, maybe the more than I want them to be. So again, you can, before you build or test this or before it shears off, you could take the thermal expansion, put these all together, do a fatigue analysis like Jorge did, and get insight into your design problem. So again, I know we're coming to the top of the hour. Just wanted to show you maybe how you could do a thermal analysis inside of Nastran In-CAD. Jorge, with that, let me just pass it back over to you.
Great. Thanks, Dave. Yeah, so, one of the things I know I've liked about In-CAD, for example, is that, how it shows you the actual distortion of it. I know I was playing around with it one time and looking at a coil, and the coil actually causing the whole thing to kind of move into it, and it showed how it actually have contact to the surfaces and roll into itself. So, just another nice little example there. But to wrap this up, thank you for those of you that stuck around for the bonus session. In summary, this Advanced FEA bonus one was to, show you that you can take it a little bit further and still use it inside of AutoCAD in something called Nastran In-CAD, a separate add-on package that can do fatigue analysis, large displacement, nonlinear materials, as well as contact analysis, heat transfer, random vibration, some of the ones we mentioned, and even bolted connection, where it allows you to actually look at a study of a bolted connection. There is a comparison sheet even that's available as well, so if anybody's interested, I can always send this out to you as well. You can always search for it as well, of course, which will show you what the differences are, what Inventor Professional will do, what Nastran In-CAD will do, and even what Simulation Mechanical will do, which is another simulation software solution we have as well available, depending on what your needs are. And again, how we can help, there's always training available. There are tutorials to get this done, and we can always help you see if, is this really a fit? And like Dave mentioned, he'll actually be out in our Southern California office next week, and if it fits into your schedule, we'd be happy to come by and see what, types of things you'd like to take a look at, or even successes as well. So we'd be more than happy to come out and visit you guys. So if there's any questions on that, I know there was a question that came up here that I wanted to see if Dave, you can, if you knew the answer to, which was,
sure.
Can Inventor perform analysis on carbon fiber components?
Can Inventor? So if I'm hearing the question right, the carbon fiber typically it can be treated as a composite, and if you need to treat it as a composite, you're going to be better off using a tool like Nastran In-CAD, which has the ability to do composite simulations. You could, if you could characterize it as a, the linear properties of it, you could do some initial analysis with Inventor. So you can do some with of the carbon fiber, but my understanding is that it's not going to capture the everything correctly. So I would hesitate to say, yeah, Inventor simulation can do it, but that's my understanding of the way composites work, is that it'd be better, or carbon fiber, typically people use some of our composite capabilities to simulate that.
Awesome. All right, thanks, Dave. There was one other question here, which was what version of Inventor is this available for? So this is, we're looking at 2016 right now. It is available for 2016.
In 2015?
As well, right? Yeah.
Yep, it'll work with 2015 as well.
Exactly.
I don't know if it goes back any earlier than that, just because it was an acquisition about a year and a half ago, so it's not 100% integrated just yet.
Right. And then a reminder, in case some of you joined a little later, that it also is embedded into SolidWorks as well. So, if you have a multi-CAD environment, you have other colleagues that, might be interested, it does work with SolidWorks also. Great. That's all the questions I see here. So thank you, everybody, for joining. I look forward to seeing you at our next session next week, which will be Shape Generator and the R2 version of Inventor, which will kind of build on this a little bit, a little FEA for you there, and free body diagrams that will be available.
Yeah, come check out the optimization that's in the new version of Inventor. I'm not going to be able to make the call, but it is slick. It is worth checking out. Just kind of the next generation of optimization and simulation, if you will.
Right. Oh, we do have one last question, Dave, here that came in that says, can welded connections be analyzed? I'm assuming that's for in-CAD.
Yeah, it can be. Yep, and not to rock the boat too much, but I think talking with KETIV, we're actually going to try to have another bonus session or another session on welding in early January to talk about how to use what's available in Inventor, what that does, and go all the way up through the progression for what you can do with another tool. So it's a great topic. We've heard of that before, and hang on with us because we're going to try to cover it more at a future date.
Exactly. Awesome. All right. Thanks again, everybody. We'll look forward to see you next week and many others as well. Thanks again, Dave, too.
All right. Thanks for your time.